from Meekum Fountain on Main Street in Houston, Texas. Toups Graphics presents Solving Linear Systems in Verbal Descriptions. In algebra, linear systems are problems that involve two unknown quantities and two equations. When solving problems with linear systems, remember you will have two equations, and your variables are usually x and y. Sometimes the equations will be in y-intercept form, and sometimes the equations will be in standard form. And most likely to get the answer, you'll use the process of substitution or elimination to solve the system of equations. Let's take a look at our first problem. Bubba Bob purchased 2 adult and 4 student putt-putt tickets for $36. Jiminy John purchased 2 adult and 2 student putt-putt tickets for $26. What is the price of each ticket? Remember, when solving problems with systems of equations, you'll need two equations. In this problem, both equations will be in standard form. Let's first take a look at Bubba Bob's equation. Remember, the equation will be in standard form. Bubba Bob purchased 2 adult and 4 student tickets for $36. So his equation would be 2x plus 4y equal 36. Now that we have Bubba Bob's equation, let's get Jiminy John's. His equation will also be in standard form. He purchased 2 adult and 2 student tickets for $26. So his equation would be 2x plus 2y equal 26. Since both equations are in standard form, we'll use elimination. Now, see if you could use the process of elimination to solve for the system of equations and find the purchase price of each ticket. Remember, to use elimination, you need to make one set of your coefficients opposites to eliminate one of the variables. If you look at your variables of x's, they're both 2x. We need to turn the bottom 2x into a negative 2x, so we'll multiply the bottom equation by negative 1. By multiplying the bottom equation of negative 1, you'll make your x's opposites. That will give us 2x plus 4y equal 36 and negative 2x minus 2y equal negative 26. Now if you add the equations, the x's will eliminate. If you were to add your equations, the x's would eliminate, giving you 2y equal to 10. Now you would divide both sides by 10 and get that the quantity of y is equal to 5. Now we'll replace 5 into one of the equations. Let's use 2x plus 2y equal 26. That would turn the equation into 2x plus 10 equal 26. To solve the equation, we'll move the constant of 10 to the right by subtracting 10. Now we have 26 minus 10 is 16, so our equation would be 2x equals 16. Now we need to divide by 2 to get the quantity of x. 2 would go into 16 8 times. So we know that the adult ticket, or x, would be $8, and the student ticket, or y, would be $5. As we bike through Rice University, let's do another systems of equations problem. Emma Sue and Lucy Claire are doing fundraisers. Emma Sue has $50 and will earn $8 for every hour she works at the car wash. Lucy Claire has $20 and will earn $14 for every hour she tutors math. At how many hours of work will the two have equal amounts of money? See if you can write the two equations needed to solve the problem. These two problems involve the growing number and starting number, or GX plus S. Let's find the growing number and starting number for Emma Sue and Lucy Claire. If you read the problem, you can find that Emma Sue's growing number's 8 and her starting number's 50. Meanwhile, Lucy Claire's growing number's 14 and her starting number's 20. If we use GX plus S, we'll get equations y equal 8x plus 50 and y equals 14x plus 20. Notice that both of these problems are mx plus b form. Now we'll use substitution to find x and y. Both of these equations are y equal, so we know that y equals 8x plus 50. We'll replace y with 8x plus 50. That will make our equation 8x plus 50 equals 14x plus 20. Now we can solve for x. Now we'll solve for x. First, we need to move the smaller quantity of x to the other side. We'll subtract 8x from both sides. That gives us 50 equals 6x plus 20. Now we'll move 20 to the left by subtracting 20. 50 minus 20 would be 30. So now we have 30 equals 6x. Now we can divide 6 into 30 and get x equals 5. Now we need to replace x equals 5 into x into the y equal 8x plus 50. We'll substitute x for 5 and get y equals 8 times 5 plus 50. Now we'll multiply 8 times 5 and get 40. So we'll have y equals 40 plus 50. The sum of 40 and 50 is 90. So at 5 hours of work, each girl will have $90. If you go back and read the original problem, the problem wants how many hours of work will the two have equal amounts. The number of hours would be 5 hours. This Toups Graphics video production of Solving Linear Systems and Verbal Descriptions is sponsored by Domain. Do you need another word to describe the x value of a function? You could use domain. And independent quantity. The independent quantity is actually the domain. The domain and independent quantity. They give your function more power. We'll be back after this commercial break. Today's video is sponsored by function. A function is an expression. A function's made up of a domain, which is our input value, which is also called the independent variable. Let's say we input a domain value of 2 into the equation. Now we have 3 times 2 plus 4, which would be 10. The answer to a function is called the range. The range is also your output value of your expression, and it's also called the dependent variable. In this instance, 10 would depend on the input value of 2. The function. It gives algebra more power. From the University of Texas Health Science Center Fountains in Houston, Texas. The Pentagon T Toups Graphics tutorial video over solving linear systems and verbal descriptions continued. Let's do a problem with a slope-intercept form and a standard form equation. An adult ticket is $7 more than a student ticket. 5 adult tickets and 8 student tickets cost $100. What is the cost of each ticket? See if you can start by writing both equations. Remember, one will be y-intercept form and one will be standard form. Let's let X be an adult ticket and Y be a student ticket. Our first sentence has our first equation. An adult ticket is, that means an adult ticket equals $7 more than a student ticket, which would be Y plus 7. That means our first equation is x equal y plus 7. The second sentence contains our second equation. 5 adult tickets and 8 student tickets cost 100. Let's look first at 5 adult tickets, which would turn into 5x. 8 student tickets would turn into 8y, and they cost or equal $100. That makes our second equation 5x plus 8y equal 100. Now that you have both equations, see if you can solve by using substitution. Since one of the equations has a variable equal to another item, we'll substitute y plus 7 in for x. That would give us 5 times y plus 7 plus 8y equal 100. Now we can solve the second equation for y. We need to first distribute 5 to y and 7. That would give us 5y plus 35 plus 8y equal 100. To solve 5y plus 35 plus 8y equal 100, we must first combine the variables of 5y and 8y. 5y and 8y would combine to 13y. The next step would be to move the 35 from the left to the right by subtracting 35. That would give us 13y equals 65. Now we need to divide 65 by 13. If you were to divide 65 by 13, you would get 5. So we know that y, or the student ticket, is $5. Now we'll substitute the 5 into the value of y in the equation x equals y plus 7. If you replace y with 5, you would have x equals 5 plus 7, which would make x, or the adult ticket, cost $12. So one adult ticket would be $12 and one student ticket would be $5. From Main Street in Houston, Texas, let's solve another problem involving systems of linear equations. Two numbers have a sum of 63. If you multiply one of the numbers by 5 and one of the numbers by 4, their sum would be 280. What are the two numbers? Using x as a first number and y as a second number, see if you can write both the equations needed to solve the system. In this problem, both equations will be in standard form. Let's look at the first sentence. Two numbers have a sum of 63, so x plus y would be 63. The second sentence says that 5 times one number and 4 times another number has a sum of 280, so 5x plus 4y equal 280. Since both equations are in standard form, use elimination to solve for the variables. See if you could use elimination to solve for the variable of x and y. Remember, to use elimination, we need to make one of the variables opposites. So let's make 4y and negative 4y opposites. We'll need to multiply the second equation by negative 4. If you were to multiply the bottom equation by negative 4, you would get negative 4x minus 4y equal negative 252. Now that the y's are opposite, they'll eliminate. 5x minus 4x is 1x or x, and 280 minus 252 would be 28. That means x equals 28. Now we'll take the value of 28 and plug it into the x into the first equation. That would make us have 28 plus y equals 63. Now we can solve for the value of y. To solve 28 plus y equals 63, we'll first subtract the 28. That would give us the answer. 63 minus 28 is 35. So the two numbers would be 28 and 35. The Pentagon T. Toups Graphics. Video of solving linear systems and verbal descriptions is sponsored by range. Do you know the output of a function? It's called the range. And dependent quantity. The range is also called the dependent quantity. Positive correlation. Is your slope of your line positive? The values of x and the values of y would have a positive correlation. We'll be back after this commercial break.
Aren't these Pythagorean triple meal deals great? I'm going to get the 3, 4, 5 meal deal. For $5, you get 4 tacos and 3 Frito chili cheese wraps. What a great deal!
That is a good deal, Dad. But I think I'm getting to get the 5, 12, 13 meal for $5. And you get a 12-inch hot dog and 13 tater tots.
Wow, what a cool deal!
I know.
You know what I'm going to think of it? I'm going to live life on the edge. I'm going to supersize my 3, 4, 5 meal deal with a scale factor of 2 and make it a 6, 8, 10 meal deal. For $10, I'm going to get 8 tacos and 6 Frito chili cheese wraps.
That's a lot of food.
Don't worry about that. I'm a manly man type of guy. It's so cool supersizing your Pythagorean triple meal deal with a scale factor. You know, you take a girl down here, use a coupon with your order, and show her how to use the scale factor. Talk about being a babe magnet.
The Pythagorean triple meal deals, only at Sonic. From Herman Park in Houston, Texas, the Pentagon T Toups Graphics video tutorial over solving linear systems in verbal descriptions continues. Let's do an age problem. The sum of Emma Sue and Mary Belle's age is 50. In 5 years, Mary Belle will be twice as old as Emma Sue. How old are they now? Use the following guide to get both equations to solve the linear system. The first sentence gives us our first equation. If you add both ages, or x plus y, you get 50. So x plus y equal 50 is our first equation. The second equation's a little tougher. In 5 years, that means you have to add 5 to the x variable and the y variable. Mary Belle will be, Mary Belle equals, that means that the quantity on the left will be Mary Belle. So let's put y into the blank on the left. Mary Belle will be twice as old. That means you need to multiply Emma Sue's age by 2. So x goes into the other blank. That gives us our equation of y plus 5 equals 2 parentheses x plus 5. Now see if you can turn the second equation into standard form. The first step would be to use the distributive property on the 2. You'll multiply the x plus 5 by 2 and get 2x plus 10. That makes our equation y plus 5 equal 2x plus 10. The next step is to move the x to the left and the 5 to the right. So we'll subtract 2x from both sides and subtract 5 from both sides. This will make our equation negative 2x plus y equals 5. Notice that both of our equations are in standard form. So we'll use elimination to find the x and y quantities. Remember, when you use elimination, you want to make one set of variables opposite. Since the y's are the same, let's make 1y plus y and 1y negative y. So we'll multiply the bottom equation by -1. If you multiply the second equation by -1, -1 times -2x is a positive 2x. -1 times y is -y, and -1 times 5 is -5. Notice that now the y's are opposites, so we can add straight down and solve for x. So if we add our equations, we'll get 3x, the y's cancel out, equals 45. To solve for x, we need to divide both sides by the coefficient of 3, and x would end up being 15. So we know that MSU is 15. Now let's replace 15 into the formula x plus y equal 15. That would give us 15 plus y equal 50. To solve for y, we would subtract 15 from both sides, giving us that y would be 35. So Emma Sue would be 15 years old and Mary Belle would be 35. Today's video is sponsored by negative exponents. Let's say you have 4 to the third power over 4 to the fifth. You could rewrite that with 3 4s on top and 5 4s multiplied on bottom. That would equal to 1 over 4 squared, which would be 1 over 16. Now let's say you take 4 to the third over 4 to the fifth again. You can subtract the exponents. Remember, you subtract the numerator from denominator, and you would get 4 to the -2, which is also 1 over 16. A negative exponent moves your answer across the fraction bar. Now see if you can do these problems on your own. The first answer would be 1 over 49. The second answer would be 1 over y to the 6th. And lastly, you would have 25 over 27. A negative exponent gives algebra more power. Solving linear systems in verbal descriptions is sponsored by the commutative property. Do you need to add or multiply in reverse order? You need the commutative property. The associative property. Do you need to add or multiply in any order? You need the associative property. And the x-intercept. Do you need to know the root of an equation? You need to find the x-intercept. From Discovery Green Park in Houston, Texas, our tutorial video continues. Let's do one more problem. Emma Sue purchased 40 flip-flops. The flip-flops cost either $4 or $7. The total cost of the purchase was $238. How many of each $4 and $7 flip-flops did she purchase? First, write the two equations. Let x equal the $4 flip-flops and y be the $7 flip-flops. Emma Sue purchased 40 flip-flops, so x plus y is going to equal 40. That's our first equation. The $4 flip-flops plus the $7 flip-flops would equal a total cost of $238. That would be the second equation. Since both equations are in standard form, use elimination to get the answer. Remember, to use elimination, we need to make one of the variables opposites. So let's make the x's -4x and +4x. That means we need to multiply the top equation by -4. If you multiply the top equation by -4, you would get -4x minus 4y equal -160. Now we can add down and eliminate our x's. That would give us 3y equals 78. Now if you divide both sides by 3, you would get y equal 26. So Emma Sue purchased 26 $7 flip-flops. Now let's plug 26 into the equation x plus y equal 40. We'll subtract 26 from both sides and get x equals 14. So Emma Sue purchased 14 $4 flip-flops and 26 $7 flip-flops. The Pentagon T Toups Graphics video tutorial solving linear systems and verbal descriptions has been sponsored by Pentagon T. Do you need to believe? You need Pentagon T. This has been a Toups Graphics Always Believe production.